Okay, so this is a test review for Algebra 2's Chapter 1 through 3 test review, and we'll just go through it as quickly as we can. This first question, your job in the instructions is to solve for the variable x, and so it's just about removing the layers that are around it from simplest to most complicated. You should always start these problems by removing addition and subtraction if it's not in a parentheses. So here we're going to minus w. Excuse me. We'll get z minus w equals, there we go, equals 3x over y. And then the next thing we want to do is try to get rid of the y down here. So we're going to times by y, because right now it's being divided. When I times by y on the left side, though, I really need to distinguish the order in which we've done things. Because we did the subtraction first, we need to maintain that that's what happens first. So we're going to put parentheses around the subtraction. That keeps us from taking the y times z, but not the w. This allows for later on, if we needed to, we could do some distribution. I am not going to distribute this at all, though, because it just makes it look messier. This looks fine like that. And then the last step, to get rid of this 3, I would just divide by 3. And I'm just going to put the whole thing over 3, meaning that my answer for x, once rewritten, would be x equals y times z minus w all over 3. And so there's the answer to question number 1. Question number 2 gives you a list of inputs and outputs, and your job is to determine whether it's a function or not. Given the fact that each input has exactly one output, meaning that if I pick an x, which is my input list, I know exactly what the y value is, what the output is. I can say that this is a function, but I also need to state y. And specifically, the reason why would be something along the lines of each input has only one output. Okay, we're trying to say that if you look at the x's, they don't have a choice. Where we could get into some trouble is if something like this 8 was, say, a 4. Well, then the number 4 would have 2 options of where to go, or 2 outputs. If that was the case, we would say it's not a function because the input 4 has more than one output. Okay? So you do need to be able to explain why. I know the wording of it might be a little different for each person, but make sure you're communicating the idea that every input cannot have more than one output. All right, now we're going to go to graph the absolute value function. Now keep in mind, I know that there's a graph of a V shape there. All that that's doing on number 3 is reminding you that what your graph should look like when you're done. It's just I'm throwing you a bone, I'm trying to help you out a little bit, so just pay attention to that. With this, typically what we always found was the vertex, where is that? And then what's the slope of the right-hand side? You know, how do we get to the right-hand side to the next dot? Those are the kind of things that we would look for. And so we're looking at our new equation, this guy, and we're trying to figure out what is its vertex, okay, and what is the slope of the right-hand side. Okay, so the slope is really easy. It's always this thing right in the very front, so it is -1/2. That tells me the graph's upside down, okay, and it has a slope on the right of 1/2 downward. But I do need the vertex, which is an ordered pair. The rule is anything that's grouped with x, which the x plus 2 is a group, I'm going to change the sign. So the x is actually going to be -2. It's not about the absolute value, it's about the grouping that exists there. And then because this -5 is sitting out here not grouped with the variable, it stays the same the way it is. Meaning that I need to go to -2, -5, put a dot. Then from there, I'm going to go ahead and follow the slope of -1/2, which means I'm going to go down 1 and over 2. Okay? And that's the right-hand side of my V. I need to do the same thing to the left. I go down 1, over 2. So think about coming over 2. Put a dot. And there's the left-hand side of my V. That's all I need to do. Do try to make sure that your vertex and slope are obvious. If you state them, great. If not, I am going to have to come down into this region and look real closely at your graph. So if you state them, I don't have to be quite as focused on your graph as on the information you present elsewhere. Number 4, I know it has the graph of the lines. That won't be there on the test. It'll just be a blank graph. So imagine that it's just that. And your job is to graph and find the solution to the 2 lines. To use our calculator or to graph them by hand, typically we want the y equals, which we see we do have over here on the right, but we don't have on the left. So we're going to rearrange this so we get y alone. So I'm going to minus x. That's going to make 3y equal 8 minus x. And then I divide by 3. Personally, because I know I'm going to throw this in a calculator, I prefer to just write it like this with parentheses around the 8 minus x. Y is alone, so it can go into the calculator. So let's grab our calculator and turn it on. I'm going to go to y equals, and there I have 8 minus x divided by 3. And my second equation is the negative 2x plus 6. When I go ahead and go to the graph, I can see that they cross over there in the top right. To check for the actual solution, we're going to press second, trace, option number 5 for intersect. And in order to get the answer, I have to press enter 3 times. Enter, enter, and enter. It tells me the solution is at 2, 2. So when I come back here, I'm going to come over 2, up 2, and put a dot. And I'm even going to say the answer is 2, 2. But I do need to get the graph of the lines. I don't have to be exact, though I could. I just need a general graph of what they look like. Now, I'm going to make this a little bit easier for those of you who maybe struggle with this. I am actually going to go and find some more points. Okay? So the way this works, obviously I can see that when x is 2, y is 2 for the first line. But also, do you see how 5, 1 is a valid point for one of the lines? So if I come over here to 3, 4, 5, I would be at 1. So I can get out my straight edge and draw a line that goes through the 2 of those. And there would be one of my lines. If I go back to the calculator, I still have the 5 for my x, but if I arrow all the way over to the right, I have negative 4 for the other line. So that would mean same 5, but I'm going to go down 4. Whoops, 2, 3, 4. Imagine that's a sequence of dots or marks. I'm going to come over to here, draw my dot. And now when I draw my straight edge, that would be an example of the 2 lines. I can still plot points to create the curve, the lines, if it makes you feel better. But in fairness, if I came in and I just said, you know what, it's basically there, and it looks like I'm crossing at 2, 2, I'm going to be happy with it. It doesn't have to be perfect. A straight edge is nice, and certainly exactness is the best, but I'm not going to grade you on how exact you were. I need to know that the answer's in the appropriate place and that I get a place where they cross correctly. The next system, I asked you to use substitution. Substitution is where you isolate a variable. Right here is the one I'm going to get alone because it's a single x. So I'm going to minus 2y, minus 2y. So that tells me that x will equal 7 minus 2y. And that information can be plugged into the other equation where x is. Give me 5 times 7 minus 2y, plus 3y equals 14. If I distribute my 5, I get 35 minus 10y plus 3y equals 14. Sorry if I'm going kind of fast. I minus the 35. I get, combining those, negative 7y equals negative 21. Dividing by negative 7, y comes out to be 3. Then if I take that information back up here and plug it in, I learn that x is 7 minus 2 times my 3. 2 times 3 is 6, 7 minus 6, x equals 1. So my answer would be 1, 3. Okay. The third option is to use elimination. To do elimination, we need the same variable with opposite signs. And so if I look here at the y's, okay, I could turn that 3y into a negative 9y. if I multiply this equation by negative 3. That would make it negative 15x minus 9y equals 28 times the negative 3 is negative 84. And this other equation, I'm going to leave the way it is. It's 4x plus 9y equals 29. If I combine my like terms, I get negative 11x. The 9y's cancel. Now that was the goal. That's the elimination that I was after, and this would be negative 55. Dividing by negative 11, I get x equals 5. Now that I know that x equals 5, I'm going to bring that information back to one of the original problems. Let's do 4 times my 5 for x plus 9y equals 29. 4 times 5 is a 20, so I'm going to minus 20 from both sides. That should cancel the 4 and 5, leaving me with 9y equals 9, so y must be 1. So my ordered pair here would be 5, 1. Just a couple more. Number 7 is a word problem. So a big piece of it is, can you take words and turn them into equations? In number 7, I talk about the math department. I said I sell 10 egg-shaped, I'm going to use B for brownie, and 3 cupcakes, and I make $8.75. Mr. Henry sells 22 of these brownies and 15 cupcakes and makes $29.75. I could use graphing, I could use substitution, or I can use elimination. It looks like an elimination problem because I could turn that 3c into a negative 15c by timesing it by negative 5. Okay, I'm going to bring that information down. That becomes negative 50b minus 15c equals negative 43.75. So I'm going to combine these two equations right here. The rewrite of number 1 and the same thing I already had here becomes negative 28b. The c's cancel, right? And I get equals negative 14. If I divide by negative 28, b should come out to 0.5, meaning it's 50 cents, okay? To figure out how much a cupcake costs, I'm going to take that information back in the top equation. That's 10 times b, which is 0.5, plus 3c equals 8.75. 10 times 0.5 is 5, so I'm going to minus 5 from both sides. That should give me 3c equals 3.75, and when I divide, C, the cupcake, is $1.25. So there's the price of the cupcake and the price of the brownie. The last thing we do on this test is the 3x3 system. And yes, it takes some time, but it is something that shows a lot of adult skills. Shows things like, you know, making sense of a problem over a long period of time, taking time and patience to get through it all. There's multiple ways to do this. I am going to choose to get rid of y. I like the 2, the 4, and the 1. I think those are all easy to work with. So for me, I'm going to start this problem by taking equation number 2, okay, times 2, and equation number 3, just the way it is. That's going to make my y's cancel, because I'll get 4x plus 2y minus 14z equals 18. And then the bottom one's not going to change. 5x, that's fine, I don't care what that is. Minus 2y, this is what I was really after, was canceling the y's. All right, plus z equals 28. When I combine these, I'm going to get 9x, my y's cancel, minus 13z equals 46. I'm going to call this equation number 4. Now I got rid of y's, so I have to get rid of y's again. I can't use 2 and 3, I have to use 1 and something. So I'm going to use 2 and 1. That's a choice I'm making. You could certainly do 1 and 3 as well, but I like 2 because it's a single y, so I like that one. So I'm going to take number 2 I'm going to times it by 4 to make a positive 4y to go with this negative 4y there. So that makes it 8x plus 4y minus times 4 minus 28z equals 36. And equation number 1, I didn't change, so it would be x minus 4y plus 6z equals negative 8. When I combine here, I'm going to get 9x. My y's cancel again, that's important. Minus 22z equals 28. Okay. And I'm going to call that equation number 5. Now I want to combine those two together, but I need to make something cancel. It looks like the 9x and 9x would work well if one of them was negative. So I'm going to take equation number 4 times negative 1 to make it negative 9x plus 13z equals negative 46. And I'm going to bring equation 5 just the way it is, having a 9x minus 22z equals 28. If I combine, my x's are going to cancel. Okay, I'm going to get a negative 9z equals negative 18, which if I divide by negative 9, z comes out to be 2. All right. Now I can take that information and plug it into one of the two equations, either 4 or 5. I'm just going to bring number 4 down here. Say I have 9x minus 13 times 2 equals 46. Well, 13 times 2 is a 26, and since it's negative, I'm going to add 26 to both sides. That should cancel that piece, meaning 9x equals 72, sorry. Which if I divide by 9, x comes out to be 8. So I have x is 8, I have z is 2, and here we go, I'm going to scroll up. Way back up here, I'm going to find the equation that has the simplest y, because that's what I'm still missing. I like this one. It's 2 times, we said x was 8, plus y, I don't know, minus 7 times z, we said was 2. And we're supposed to get 9 from that. So this is 16 plus y minus 14 equals 9. If I look at the 16 and the minus 14, that's a 2, so this would be y plus 2 equals 9. Therefore, y must be 7, because you subtract the 2. And there's our third answer. So our final answer was that x is 8, y is 7, and z is 2. All right. That's all of it. If you have questions, come in before school or see me before you take your test, and we'll go over them. Thanks. Good luck.